Have you ever seen a bright, thin line of light in a movie or at a rock concert? That, my friends, is a laser. It looks like something from the future, but it's a real piece of science that we use every single day. A laser is not just any light, it is a very special, very powerful kind of light that we have learned to create and control. From the checkout scanner at the grocery store to the tools doctors use to perform delicate surgery, lasers are everywhere. They are one of the most important inventions of the last 100 years, and they started with just a little bit of scientific curiosity. Think about that. An idea became a tool that has truly changed our world in so many amazing ways. The story of the laser is a fantastic example of how science works. It begins with a thought, an idea about how the universe operates. Then, scientists and engineers take that idea and start to experiment. They build things, they test things, and sometimes, after a lot of hard work, they create something brand new and revolutionary. The laser didn't just appear overnight. It took decades of brilliant minds building on each other's work. It's a journey from pure theory, just thinking about light, to a practical tool that you can hold in your hand. This journey shows us the power of science to turn imagination into reality, and that is just incredible. Before we had lasers, the idea of creating such a pure and powerful beam of light was like a dream. Regular light, like the light from the sun or a light bulb, spreads out in all directions. It's a big, beautiful mess of different colors and waves going everywhere at once. But scientists wondered, what if we could organize light? What if we could make all the light waves march together in a perfect straight line, like a well-trained army? This simple question led to one of the most versatile and powerful tools ever created by humans. It is a testament to what we can achieve when we ask, what if, and then use science to find the answer. So, let's get ready to explore this amazing invention. We will look at what makes laser light so different from the light you see every day. We will travel back in time to meet the scientists whose big ideas made lasers possible. We'll see how the very first laser was built and how it worked. Then, we will discover all the different kinds of lasers that exist today and the incredible jobs they do for us. From helping us communicate across oceans to entertaining us with light shows, the laser is a true marvel of modern science. Consider this. The world you live in today would look very, very different without it. Science is the key. First things first, what does the word laser even mean? It's not just a name, it's an acronym. That means each letter stands for a word. Laser stands for light amplification by stimulated emission of radiation. Whoa, that's a mouthful. But don't worry, we can break it down. Light amplification means making light stronger. Stimulated emission of radiation is the special science trick that makes it happen. It's all about getting atoms excited, and then telling them to release their energy as light in a very specific, organized way. So, a laser is basically a machine for making a super strong, super organized beam of light. It's a cool name for a very cool process. Now, how is laser light different from the light from, say, a flashlight? A flashlight sends out what we call incoherent light. Think of it like a crowd of people all running out of a door at once. They are all going in roughly the same direction, but they are jumbled, they spread out, and they are a mix of different energies. The light waves are all messy and out of sync. This is why a flashlight beam gets wider and weaker the farther it goes. It's useful for lighting up a dark room, but it isn't very focused or powerful over a long distance. It's just not organized enough for special jobs. Laser light, on the other hand, is coherent. This is the big, important difference. Imagine that same crowd of people, but now they are a marching band. Everyone is stepping at the same time, moving in the same direction, and staying in perfect formation. That's what the light waves in a laser do. They all travel together, perfectly in step. This property is called coherence. Because the waves are all lined up and working together, they don't spread out very much. The beam stays narrow, straight, and strong over very long distances. This is why a simple laser pointer can make a tiny dot on a wall far across a room. This organization gives laser light two other special properties. First, it is monochromatic, which means it is made of just one single color, or wavelength, of light. A light bulb produces a mix of many colors that we see as white or yellowish light, but a laser produces a very pure red, or a pure green, or a pure blue. Second, it is collimated, which means the light rays are almost perfectly parallel to each other. This is why the beam stays so tight and doesn't spread out. These three things, being coherent, monochromatic, and collimated, are what make laser light a powerful tool for science, industry, and so much more. The story of the laser doesn't start with someone trying to build a laser. It starts much earlier, with one of the most famous scientists of all time, Albert Einstein. Way back in 1917, Einstein was thinking about how light and matter interact. He came up with a wild idea. He predicted that if you had an atom that was already excited with energy, you could hit it with a particle of light, a photon, and it would release a second photon that was an exact copy of the first one. They would have the same color, the same direction, and be perfectly in sync. He called this amazing process stimulated emission. It was just a theory on paper, but it was the seed from which the laser would eventually grow. For many years, Einstein's idea was just that, an idea. No one knew how to actually make it happen in the real world. Then, in the 1950s, a group of brilliant scientists started to figure it out. Two scientists in Russia, Alexander Prokhorov and Nikolai Basov, and a scientist in the United States named Charles Townes, were all working on a similar problem. They weren't trying to make a light beam, though. They were trying to make a beam of microwaves, which are another kind of electromagnetic radiation, just like light. They figured out how to use Einstein's stimulated emission to amplify microwaves. In 1954, Charles Townes and his students built the first working device. They called it a MASER, which stood for microwave amplification by stimulated emission of radiation. Does that sound familiar? It's almost the same as the acronym for laser. The MASER was a huge breakthrough. It proved that stimulated emission wasn't just a theory. It was a real physical process that could be used to create a powerful, coherent beam of radiation. For this incredible work, Townes, Prokhorov, and Basov later shared the Nobel Prize in Physics. They had built the scientific foundation and shown the world the way. Once the MASER was invented, the race was on. Scientists all over the world realized that if you could do this with microwaves, you could probably do it with visible light too. The MASER was the older cousin of the laser. Charles Townes and another scientist, Arthur Shallow, wrote a very important paper in 1958 that described in detail how you could build an optical MASER, what we now call a laser. They laid out the blueprint, explaining how to use a special tube with mirrors at each end to build up the light. The stage was set. The theory was complete. All that was left was for someone to actually build it. With the scientific recipe in hand, laboratories around the world began a friendly but intense race to build the first working laser. Many famous research labs with lots of money and people were working on it. They were trying to use gases, believing that would be the easiest way to make a laser work. But the person who succeeded was not from one of those big teams. His name was Theodore Maiman, a physicist working at Hughes Research Laboratories in California. Maiman decided to try a different approach. He thought he could build a laser using a solid material, something everyone else thought was too difficult. Maiman chose to use a synthetic ruby crystal. This wasn't just any ruby, it was a special rod of pink ruby, grown in a lab, with its ends polished to be perfectly flat and coated with silver to act as mirrors. He had a powerful idea for how to get the atoms inside the ruby excited. He decided to use a bright, flashing light, like the kind you would find in a photographer's flash lamp. His plan was to wrap this powerful flash lamp around the ruby rod. The intense burst of light from the lamp would pump energy into the chromium atoms inside the ruby, getting them all excited and ready to release their light. On May 16, 1960, the day came. Maiman and his assistant placed the small ruby rod inside the spiral flash lamp and prepared for the experiment. When they fired the lamp, it produced an incredibly bright flash of white light. For a split second, that light poured energy into the ruby crystal. Inside the crystal, Einstein's theory of stimulated emission came to life. The excited chromium atoms began releasing photons. These photons bounced back and forth between the mirrored ends of the rod, stimulating other atoms to release identical photons. The light inside the rod amplified, growing stronger and more organized with every bounce. Then, for an instant, a brilliant, intense pulse of deep red light shot out from one end of the ruby rod. It was the first man-made laser beam. Maiman had done it. He had created the world's first working laser. His device was small, simple, and it worked beautifully. When he first tried to publish his results, some scientific journals rejected his paper, thinking it wasn't that important. But soon, everyone realized the magnitude of his achievement. That first flash of ruby red light was the beginning of a revolution. It was the moment the laser stepped out of theory and into the real world, ready to change everything. After Maimann's first ruby laser, scientists and engineers started inventing all kinds of new lasers. Today there isn't just one type of laser, there are many. They can be grouped based on what material they use to create the light, what we call the gain medium. One of the first types to be developed was the solid-state laser, like Maimann's original. These lasers use a solid crystal, like ruby, or a special crystal called YAG, doped with certain atoms. They are very powerful, and are often used in industry for cutting and welding thick metal. They are also used in medicine for surgery, because their powerful, focused beam can cut tissue very cleanly. Another very common type is the gas laser. Instead of a solid crystal, these lasers use a gas, or a mixture of gases, inside a tube. The first gas laser, the helium neon laser, was invented shortly after Maimann's. It produces a classic bright red beam and is often used in schools for science demonstrations and for barcode scanners in supermarkets. Other gas lasers, like carbon dioxide lasers, are extremely powerful. They produce an invisible infrared beam that is perfect for industrial cutting of wood, plastic, and fabric. You might be wearing clothes that were cut by a carbon dioxide laser. Next, we have liquid lasers, which are also called dye lasers. These are really interesting because their gain medium is an organic dye, like a special ink, dissolved in a liquid solvent. The coolest thing about dye lasers is that you can change their color. By changing the type of dye, or by adjusting the optics inside the laser, you can tune the laser to produce a very specific wavelength of light. This makes them incredibly useful for scientific research, especially in chemistry and spectroscopy, where scientists need to study how different materials absorb very specific colors of light. Finally, we have two of the most important types of lasers in our modern world: semiconductor lasers and fiber lasers. Semiconductor lasers, also known as laser diodes, are tiny. They are the little chips you find in laser pointers, Blu-ray and DVD players, and in the fiber optic communication systems that power the internet. They are small, efficient, and cheap to make. Fiber lasers are a newer type where the laser beam is generated and amplified inside a long, thin optical fiber. They are becoming very popular in industry for marking, engraving, and cutting because they are very reliable and produce a very high-quality beam. It is hard to imagine our world today without the laser. This incredible beam of light has transformed almost every part of our lives. In medicine, doctors use lasers as a precise bloodless scalpel for delicate surgeries on the eye, skin, and internal organs. They can be used to destroy cancer cells, remove kidney stones, and even get rid of tattoos. The laser allows for surgeries that are safer, faster, and have quicker recovery times. Think about that. A beam of light can help heal people. That is a true scientific marvel, something that would have seemed like magic just a few generations ago. What an amazing tool for doctors and patients. In industry and communication, the impact of the laser is just as huge. Lasers are used to cut, weld, drill, and mark materials with incredible precision, from giant sheets of steel for cars to tiny electronic components for your phone. But perhaps the biggest change has been in communication. Billions of tiny laser diodes are flashing on and off billions of times per second, sending information as pulses of light through a global network of fiber optic cables. Every time you watch a video online, make a phone call, or send an email, you're using lasers to send that data across cities and oceans at the speed of light. Of course, lasers are not just for serious work, they are also for fun. They are used to create spectacular light shows at concerts and events, painting the night sky with brilliant colors and patterns. In your home, they read the information from Blu-ray and DVD discs to bring you movies and music. And in science, lasers are essential tools. They are used to measure distances with incredible accuracy, to study the properties of atoms, and even to cool atoms down to temperatures colder than outer space. The laser has become one of the most versatile and important tools in any modern research laboratory. Because lasers can be so powerful, we must always remember to use them safely. Even a small laser pointer can cause permanent eye damage if you shine it directly into someone's eyes. Powerful industrial and medical lasers can cause serious burns or start fires if they are not used correctly by trained professionals. That's why there are many safety rules and warning labels for laser products. By respecting the power of the laser, we can continue to use it to do amazing things. The laser is a perfect example of how a single scientific discovery can grow and branch out, creating a future that its inventors could have only dreamed of.